Most people believe belly fat burns when they sweat more. They think the solution is more crunches, longer cardio sessions, or cutting one specific food forever. But biologically, belly fat does not respond to effort alone. It responds to hormonal signals. The fat around your abdomen, especially visceral fat, is not just stored energy. It is metabolically active tissue. It releases inflammatory molecules like tumor necrosis factor alpha and interleukin 6. It influences insulin resistance and cardiovascular risk. And here is the part most people never hear. You can exercise daily and still struggle with belly fat if the hormonal environment is wrong. The real switch that determines whether belly fat burns is not how hard you train. It is whether your body is in a state of lipogenesis or lipolysis. In other words, are you storing energy or are you releasing it? Insulin levels, cortisol rhythms, mitochondrial efficiency, and muscle activity determine that answer. Not ab workouts alone. In this video, we are going to break down what truly burns belly fat according to physiology. We will explain the exact biological processes that release stored abdominal fat, and more importantly, how you can activate those processes naturally at home. Because once you understand the mechanism, fat loss stops being confusing, it becomes predictable biology. Before we talk about workouts or diets, we need to define one word: lipolysis. Lipolysis is the biochemical process that breaks down stored triglycerides inside fat cells. Without lipolysis, fat cannot be burned. Inside each adipocyte, triglycerides are stored as energy reserves. When the body needs energy, enzymes such as adipose triglyceride lipase and hormone-sensitive lipase are activated. These enzymes split triglycerides into free fatty acids and glycerol. The free fatty acids then enter the bloodstream. They travel to tissues such as muscle and liver. Inside mitochondria, they undergo beta oxidation to produce AMP. That is what fat burning truly is. It is not sweating, it is not muscle soreness, it is mitochondrial oxidation of fatty acids. But here is the critical regulatory factor: insulin suppresses lipolysis. When insulin levels are elevated, hormone-sensitive lipase activity decreases. Fat remains stored, even if you are exercising. Frequent snacking, high glycemic meals, and constant grazing keep insulin elevated throughout the day. This creates a hormonal state that favors storage rather than release. Research published in the Journal of Clinical Investigation confirms that insulin is the primary inhibitor of fat breakdown. When insulin declines, lipolysis increases. This does not mean extreme fasting is required. It means structured eating patterns that allow insulin to rise and fall appropriately. When you reduce refined carbohydrates, increase fiber intake, and avoid constant snacking, insulin becomes more stable. Stable insulin creates windows where lipolysis can occur. Fat burning is not random, it happens when hormonal permission is granted. If insulin remains chronically elevated, that permission is denied. When insulin declines, lipolysis activates. That is the first and most fundamental mechanism behind belly fat reduction. Now that we understand lipolysis, we need to examine another critical regulator: AMP-activated protein kinase, or AMPK. AMP functions as a cellular energy sensor. When your cells detect low energy availability, AMP becomes activated. This activation shifts the body from energy storage to energy production. During physical activity, AMP levels drop and AMP levels rise. This biochemical shift activates AMPK. Once activated, AMP stimulates fatty acid oxidation and inhibits lipid synthesis. In simple terms, AMP tells your body to burn fuel rather than store it. It also increases mitochondrial biogenesis. That means your cells build more mitochondria. More mitochondria increase your capacity to oxidize fatty acids efficiently. This is why consistent movement matters. Resistance training, high-intensity intervals, and even brisk walking activate AMP pathways. You do not need advanced machines to stimulate this mechanism. However, there is an important nuance. Excessive training without recovery elevates cortisol. Chronically elevated cortisol can counteract fat loss by promoting visceral fat storage. This creates a paradox. More exercise is not always better. More intelligent exercise is better. Moderate intensity training performed consistently activates AMP without overwhelming the stress response. Muscle contractions also stimulate glucose uptake through GLUT4 transporters independent of insulin. This reduces circulating glucose and lowers insulin demand. Lower insulin combined with activated AMP creates a metabolic environment favorable for fat oxidation. Research published in metabolic physiology journals consistently shows that AMP activation is central to improving insulin sensitivity and enhancing fat metabolism. The goal is not exhaustion. The goal is metabolic signaling. When you move your body regularly and recover properly, you activate the internal switches that promote belly fat reduction. Fat burning is not about punishment. It is about activating the right biochemical pathways. Now we need to talk about a hormone that many people overlook: cortisol. Cortisol is released through activation of the hypothalamic pituitary adrenal axis. It rises in response to physical stress, Psychological stress and sleep deprivation. In short bursts, cortisol is adaptive. It mobilizes glucose and free fatty acids to provide immediate energy, but chronic elevation changes the equation. Visceral fat tissue contains a high density of glucocorticoid receptors. This makes abdominal fat particularly sensitive to cortisol signaling. When cortisol remains elevated, lipoprotein lipase activity increases in visceral adipose tissue. This promotes triglyceride uptake and storage in the abdominal region. In addition, cortisol can impair insulin sensitivity over time. When insulin sensitivity declines, the pancreas compensates by secreting more insulin. Higher insulin further suppresses lipolysis. This creates a biological trap. Stress increases cortisol. Cortisol encourages visceral storage. Insulin rises to compensate. Lipolysis is inhibited. Research published in the journal Obesity has demonstrated strong associations between chronic stress markers and increased abdominal adiposity. Sleep deprivation amplifies this pattern. When sleep is restricted, evening cortisol levels remain elevated instead of declining. At the same time, leptin decreases and ghrelin increases, driving hunger and cravings. This explains why people under chronic stress often notice fat accumulating specifically around the waist. The solution is not eliminating cortisol entirely. That would be impossible and unhealthy. The goal is restoring normal circadian rhythm. Regular sleep, structured eating, moderate exercise, and stress regulation techniques stabilize cortisol amplitude. When cortisol rhythms normalize, visceral fat storage pressure decreases. Lipolysis becomes more efficient. Sometimes the most powerful fat-burning strategy is not adding another workout. It is removing chronic stress signals that tell your body to hold on to abdominal energy reserves. Now let us examine a factor that is often underestimated: skeletal muscle. Muscle is not just for movement. It is the largest metabolic organ in your body. After you eat, glucose enters the bloodstream. To prevent blood sugar from rising excessively, glucose must be transported into cells. Insulin normally facilitates this process. However, during muscle contraction, a different pathway activates. GLUT4 transporters move to the muscle cell membrane independent of insulin. This allows glucose to enter muscle cells without requiring large insulin spikes. Lower insulin demand means reduced inhibition of lipolysis. Remember, insulin suppresses fat breakdown. The more muscle tissue you have, the greater your total glucose disposal capacity. This improves insulin sensitivity systemically. Improved insulin sensitivity means lower baseline insulin levels throughout the day. Lower insulin levels create more opportunities for lipolysis. Resistance training also increases resting metabolic rate. Muscle tissue is metabolically active even at rest. It requires energy for maintenance and repair. Over time, increased lean mass raises total daily energy expenditure. This makes sustaining a caloric deficit more achievable without extreme restriction. A meta-analysis published in Sports Medicine confirms that resistance training reduces visceral fat even in the absence of dramatic weight loss. This highlights an important distinction. The scale may not change dramatically, but body composition improves internally. You do not need heavy machinery to stimulate this effect. Bodyweight squats, push-ups, planks, and controlled core movements activate similar pathways. Muscle is metabolic leverage. The more you preserve and build it, the easier fat oxidation becomes. Belly fat reduction is not just about eating less. It is about increasing your body's capacity to manage and utilize energy efficiently. Now we address one of the most overlooked fat-burning mechanisms: sleep. Many people sacrifice sleep while trying to lose weight. Biologically, this is counterproductive. During deep sleep, the body releases growth hormone in pulsatile bursts. Growth hormone stimulates lipolysis and supports tissue repair. It enhances the mobilization of free fatty acids from adipose tissue. When sleep duration is reduced, growth hormone pulse amplitude declines. Fat oxidation capacity decreases. At the same time, sleep restriction alters appetite hormones. Leptin decreases, ghrelin increases. Hunger intensifies, especially for high glycemic carbohydrates. Insufficient sleep also reduces insulin sensitivity. This means more insulin is required to manage the same amount of glucose. Higher insulin suppresses lipolysis. A controlled study published in Annals of Internal Medicine demonstrated that sleep restriction during calorie reduction reduced fat loss by more than half. Participants lost weight, but a larger proportion came from lean mass instead of fat tissue. This creates a dangerous illusion. The scale moves, but metabolic health worsens. Sleep is not passive rest, it is an endocrine event. Cortisol rhythms reset, growth hormone rises, insulin sensitivity improves. 7 to 9 hours of consistent sleep stabilizes these pathways. When hormonal rhythms align with circadian biology, fat oxidation becomes more efficient. Before adding more cardio or cutting more calories, evaluate your sleep. Because without adequate recovery, the body prioritizes survival over fat release. True belly fat burning often begins the night before. Let us end with one final misconception. Sweating is not fat burning. Sweat is water lost through crying glands. It regulates temperature. It does not represent triglyceride oxidation. When fat is oxidized, it is broken down into carbon dioxide and water. Most fat mass leaves the body through exhaled carbon dioxide. You literally breathe out fat at the molecular level. Chasing sweat through extreme workouts may temporarily reduce scale weight. But that weight is water. It returns with hydration. True fat loss depends on hormonal balance and mitochondrial oxidation. Low insulin permits lipolysis. Activated AMPK increases fat utilization. Stable cortisol prevents preferential visceral storage. Adequate sleep enhances growth hormone-mediated fat mobilization. Fat burning is not dramatic, it is biochemical. When these internal signals align, belly fat reduction becomes a predictable outcome of physiology. Understanding this shifts your strategy. You stop chasing exhaustion. You start optimizing biology. Belly fat does not burn because of motivation alone. It burns when the internal biochemical environment shifts. Lipolysis must be activated, insulin must decline, AMP-activated protein kinase must signal energy demand. Cortisol rhythms must normalize. Growth hormone must rise during deep sleep. These are not fitness slogans. They are physiological mechanisms. When insulin remains chronically elevated, fat stays stored. When stress is constant, cortisol favors abdominal accumulation. When muscle mass is low, glucose disposal weakens. When sleep is restricted, fat oxidation efficiency declines. But when these variables improve, the body responds consistently. Insulin stabilizes, lipolysis increases, free fatty acids are oxidized in mitochondria, visceral fat gradually decreases. The human body is not confused. It follows hormonal instruction. This is important. You do not need extreme diets. You do not need punishing workouts. You do not need metabolic hacks. You need consistency in the variables that control energy storage and release. If you have diabetes, thyroid disorders, adrenal conditions, kidney disease, or take medications that influence glucose or cortisol regulation, consult your physician before making dietary or exercise changes. Avoid severe caloric restriction or excessive training. Sustainable change respects biological limits. Fat loss is not about fighting your body. It is about aligning with its design. If you want to understand what your body is truly doing beneath the surface, subscribe to What Science Reveals. Because when science becomes clear, transformation stops being guesswork and starts becoming physiology.